All right, this is Mr. H. I'm not sure what happened to my original video, but I did a video on percent change, calculating percent change, and I wasn't able to load it up to YouTube. So I'm going to do another one and then load this one. All right, so let me start. I've gone over this before in class, but I wanted to take another stab at it. So basically what I want to do is I want to show you guys, hopefully, easy way to calculate percent change and show you an easy way to remember it using some images that I think will help. So finding percent change or finding the percent increase or the percent decrease, those are all the same kind of questions, all right? And let's just go now. So here, the next thing that I want to show is the key idea for calculating percent change is you have to be able to tell what occurred first and what occurred second. That's pretty much all you really need to do. You got to be able to tell me, or you got to be able to decide what went first, what went second. Sometimes it's pretty obvious, sometimes it's a little bit more subtle, but you still need to be able to tell what happened first, what happened second. All right, so next thing, okay, here's a picture of my son. His name is Gabriel. This is when he was about 1.5 years old. Gorgeous baby. He's a wonderful son. This is going to be one of the images that we're going to use when we're calculating percent change. Now, here's another image that we're going to use when we're calculating percent change. I call this guy Elder because he's an elderly man. I don't know how old he is, but I know he's old, right? So those two images are going to be important because what you need to be able to decipher is who occurred first. Which one occurred first, or who occurred first in this? Was it my son Gabriel or was it Mr. Elder? Well, you should all be able to say Mr. Elder happened first. My son did not. Okay, I'm crossing it out, right? Usually the way that we ask this is we go, who was born first, right? That's how we normally ask it. And that would be an easier question to answer, but still it's the same thing. He was born first. He was born not first. He might have been born second or third, but he wasn't born first. The reason that I think this is important is when you're calculating percent change, the way you calculate percent change is you take the thing that occurred first and you divide it by the thing that occurred, well, let me say that again. I said it backwards. The thing that occurred second, you divide by the thing that occurred first. Second divided by first, you subtract 1, that's going to give you the percent change. This symbol here is delta, which means change, right? Occurred second divided by occurred first minus 1 equals percent change. I know that might be a little confusing, so we're going to do a couple examples. First thing, it says last year, 950 people. So I'm going to circle that. Last year, actually, let's get a different color. I like red for this. All right, so it says last year, 950 people attended a town's annual parade. This year, 1,520 people attended. What was the percent increase in attendance from last year to this year? So we're trying to find the percent increase from last year, that's the beginning, or that's the first year, and then this year is the second year. So second goes on top, divided by the first. Okay, so the last year's number is that occurred first. This year's number is 1520. You subtract 1, and all right, Gabe, that was my son photobombing me. Minus 1 equals percent change. So all I need to do now is I need to go and I need to do 1520 divided by 950 minus 1 equals 60% or 0.6. All right, so that's going to be 0.6. That's the same thing as 60%. Our answer would be C. I don't know why it's doing that. C. It should be C. All right, so remember, the second divided by the first minus 1 gives you percent change. The second thing was 1520. The first thing was 950. So that would be your answer. Now let's look at the next one. Here's another example. This was actually from Khan Academy. From the assignment that you guys were supposed to do for the May 4th week. It says Finley's pumpkin had a mass of 6.5 kilograms before he carved it. After carving it, the pumpkin had a mass of 3.9 kilograms. It says, what was the percent decrease in the mass of the pumpkin? All right, so we need to establish what happened first, what number was first, what number was second. The first number, we started with 6.5 kilograms. The second number is 3.9 kilograms. So what we're going to do is we're going to go, the first number is 6.5. The second number is 3.9. So 3.9 divided by 6.5 minus 1 equals percent change. So all you have to do, go to your calculator, 3.9 minus or divided by 6.5 minus 1 gives you a negative 0.4. Now, decrease is associated with the minus. That's what the minus represents. It means it went down. If it's a negative percent, that means it's decreasing. If it's a positive number, it means it's increasing. All right, so the answer here is 40%. Now, you can check this. You can check everything. Well, this is good, 40%. And let me kind of wrap this up. The whole idea here is we want to be able to do this. The second number divided by the first number minus 1 gives you the percent change. That's how you find percent change. All right, guys. I'm signing off for now.